Hey everybody, welcome. I'm really excited to be here. I'm Brendan Burns. I'm going to be talking about why you should care about microservices. And I've been working on various microservices for a long time, and more importantly, thinking about sort of the motivations for why we're interested in this sort of approach to designing our distributed systems. So hopefully this talk is interesting. This is a first time really that I'm giving this talk. I've given variants of it in the past, but this is the first one for this deck. That's always an exciting experience. So we'll see how it goes, but hopefully it will go well. All right, so why do I care about microservices? I actually don't think this is the important question, because really, I hope that you're not necessarily interested in why I like things or in why I'm interested in things, but rather I think it's more important for you to say, why do you care about microservices? Because ultimately, this is about how you and your teams build your services and build your products. And so I'm going to really hopefully turn the question around and not talk about why I care about them, but why I think you should care about them. And so why should you care about microservices? Well, I think you don't, actually. And in addition, if you maybe thought, well, I actually do care about microservices, I would say you shouldn't care about microservices. And so with that, I think my talk is done. So thanks, and we'll give you the 50 minutes back. No, I'm kidding, actually, about that. But I am serious about the fact that I don't actually think that you should care about microservices in and of themselves, right? I think too often we get hung up on, the hip ideas about how to build something, or the new technology, or the new approach, or the thing that someone else was talking about when we were talking to them at a conference, back when we talked to people when they were at conferences. I think, and those are really ultimately bad reasons for choosing a technology or choosing an approach to building your software. Just because everybody is talking about microservices as being better than monoliths, if you're happy with your monolith and it's working for you, you shouldn't change, right? I mean, there's no reason to, if everything is going well, there's no reason to change. And yet people are changing. And I think there's a reason for that, and there's a lot of reasons for that. So there are good reasons to go to microservices, but they're not microservices in and of themselves, right? We don't want to go and do things just to be buzzword compliant, or to dress up our resumes, or to make our CTO happy. We want to be grounded in what we actually care about. So the question then is, what do you care about? Right? If we are going to talk about microservices, and I do promise I'm going to spend the rest of the hour talking about microservices, what is the thing that you actually do care about? And what are the things that you actually care about that are then going to motivate an interest in microservices and an interest in taking your existing applications or building new applications in this paradigm? Well, for starters, I think you care about your product, right? Ultimately, at the end of the day, we are building software because we're excited about the software that we're building, right? We're excited about the characteristics, the features, the pieces of the product that we want to get out to people, right? And we care about agility, we care about ability to fix bugs, we care about ability to take this idea that is in our heads and turn it into a reality that people can use, right? So you care about your product. I hope also that you care about your users, right? Because it's one thing to build a product that matches up with your expectations and your desires and what you think should be out there. But ultimately, if it's not delighting someone, if it's not being useful for someone, I mean, it's fun, I guess, to build stuff, and I do actually like to build stuff. But ultimately, what I really like to do is build stuff that other people find useful, right? So I hope, in addition to caring about your product and caring about getting all the features that are in your head out into the market, you care a lot about your users, and you want to make sure that the product that you're developing is reliable, doesn't have downtime, doesn't get hacked and spend 4 days down like my watch did recently. You care deeply about not just delivering this thing into the world, but delivering it in a way that is useful to your end users, and also probably iterating along the way as you pay attention to what they need and the features that you need to help develop in order to continue to delight them along the way. Similarly, there's a ton of user expectations around multiple screens, around, automatic data saving. We live in a world now where the expectations of what you need to deliver when you're delivering a piece of software are extremely high, right? And those are user-driven expectations, right? They are not sort of an inherent characteristic. They are something that users come and demand, right? That data be the same when I'm on my laptop as well as I'm on my phone, when I switch computers, when I go to a different network, and that I get to access that data, 24/7, every single day of the week, and all throughout the year. So all of these features are things that I hope that you care about deeply. But in addition to your product and your users, I hope also that you care about your team, right? Because at the end of the day, we're working together to build this software, and oftentimes when we're delivering it out into the real world at 24/7, we're actually monitoring and paying attention to that software. And there's a lot of human process that goes into both the process of building as well as the process of maintaining this software. And I hope that you actually care about those teams that are doing that. I think that we've all been in situations where we spend 80% of our day not feeling productive because of rote busy work that we have to do, or bugs that we just can't have the right tools to sort out, or processes that are bloated and heavy and difficult to use, bureaucracies around ticketing systems and waiting for approvals and coordinating with a bunch of teams and attending countless meetings on Teams. I hope that you care about your teams. You want them to be happy. You want them to be productive, and you want them to interact well together. And I would say that again, all of this comes as motivation for why there's an interest in caring about microservices, right? So I said at the beginning, you shouldn't care about the tech or you shouldn't care about the design. But I hope that you do care about your product. I hope you do care about your users. I hope you do care about your teams. And I believe strongly that a microservices architecture is going to help you with those things that you actually do care about. And so instead of just tech or design for design's sake, actually we're going to walk through, I hope, some explanations about how I think this is really useful for addressing all of those things that you actually do care about. I wanted to take this moment to say this has actually happened before, right? Repeatedly, actually, as it turns out. Throughout the history of software development, we have come and we have, taken time and said, hey, actually, the software development that we're doing is too hard. Our teams are frustrated. They can't work well together. They're doing repetitive things. Whatever it is, we need to change tech, right? And I think one of the first moments that I kind of personally experienced was the growth of object-oriented programming in the mid-'80s, which I think you can see, and the growth of really software engineering as a discipline. And I think you can really see that as a reflection of the fact that in some ways, it's kind of the original microservice, right? Saying, hey, I'm going to take this, monolithic C program and break it up into a bunch of classes and a bunch of interfaces and use libraries and shared code and a bunch of other things. It wasn't a microservice in the sense of like distributed system or doing networking, but really object-oriented programming is microservices in the scale of an individual executable. And of course, over time, things have happened, and all those objects kind of got a little bit out of control and became fairly heavy themselves. And then we started saying, oh, actually, we're going to break up those executables, use network APIs and things like that. But really, the same ideas that motivated that original sort of destructuring of code in the early to mid '80s is in some ways exactly what's happening now. And it actually in some ways also happened earlier in the service-oriented architecture of the sort of early 2000s. It was that's sort of a precursor to a lot of this, I think. So I think this is a repetitive pattern. I don't actually think I think we give it a new name every once in a while. But really, it's a reflection of the fact that building software is hard, right? And so microservices are just another reflection on the fact that building software is hard. Except for it actually turns out that building software isn't hard. I mean, obviously, you have to learn how to write code. You have to get some degree of sense of how to design things, put them together, learn libraries and all that sort of thing. But the actual act of building software, I think, for each of us individually is actually not that challenging anymore, right? It was at one point. But tooling has gotten a ton better. We've spent a lot of time in the industry. We've gotten actually quite good at building software individually. The challenge is actually that building software as a team is very hard, right? And so it's not that the act of writing the code is particularly hard. I mean, sometimes there's a hard problem or a hard bug, but the act of writing the code is really not the hard part. The fact that you have to get a whole bunch of people to work together efficiently in different locations, with different expectations, with different approaches, different design aesthetics, different levels of confidence that the unit test is working correctly, and possibly even different skill levels, means that it's extremely challenging to build software, right? But it isn't actually the coding part, I don't think. It is, in fact, actually the team part. And so I would actually argue that microservices aren't really an architecture for delivering software, although there are arguments you can make about reliability and things like that. But I think ultimately what they come down to is the fact that microservices are about scaling teams, right? And so this is really, I think, what we're trying to get at every time we talk about, when we talked about object-oriented, when we talked about service-oriented architectures, when we talk about microservices, when we talk about whatever the next thing that we talk about is. What we're really talking about is the fact that scaling teams is hard, like really hard. And so like at some level, I always, one of the things I'd like to say to people is that technology changes all the time, right? Technology changes, every year, even newer. .NET 5 has just come out, so tech continues to change and evolve. Humans change on a much, much longer scale, right? And so I think one of the things to reflect on is that as we keep changing this tech, we're actually just continuing to try and solve some of the inherent problems in humans, because we can't really change humans with the same pace that we can change tech, right? And so I think in general, we look back, we can see the same patterns emerging sort of over and over again, because ultimately it's about the humans, not about the technologies. There's a ton of research and anecdotal evidence and my own personal experience that the ideal team size is 5 to 6 people. Right, and this has sort of been characterized as the 2 pizza team, or the single room startup, or the garage startup, or whatever it happens to be. But I think whatever your favorite sort of metaphor or analogy for it is, this feels very real to people, right? So taking a look at why this is the case, well, you can all sit in one room, right? Well, not anymore apparently, as it turns out, but you can at least sit in a virtual room. Where you can, communicate with each other and kind of have that daily experience of like, hey, how's it going? Talk about the weekend, talk about your pets, talk about your kids, talk about your, spouses. Have that kind of relationship where you actually have a personal relationship. It's not just a relationship that's based on the fact that, I have to work with that team over there. I have to work with that team in that other office. Similarly, if the amount of code that 5 to 6 people can spit out, like you can actually pretty much keep it all in your head, right? There's just not like the volume of code. I mean, over time, I guess eventually, you're gonna not be able to keep it all in your head. But like the amount of code that 5 to 6 people can churn out, basically most people can keep all that code in their head all the time, right? And that's really, really valuable because, of course, it means that you don't have to swap in every time, so code reviews are faster. It means that you don't do things like just kind of like rubber stamp a code review and not really understand the implications. So, the ability to understand all of the code that's going into your project is a huge benefit of sort of these small team sizes. Additionally, you can understand your product, right? So I think, when you look at really large scale products, let's say a PowerPoint or a Windows or even a Kubernetes, it's hard to keep every single piece in your head or even necessarily know about stuff. Like people are constantly saying, oh, what about this sort of esoteric Kubernetes feature over here, and assuming that sort of I have deep understanding, and I'm like, well, I didn't have anything to do with the development of that feature, and I haven't used it, so I don't necessarily understand it, right? So past a certain scale, it is actually hard to keep the focus, the product in your head. Right, but at a small scale, you can keep the product in your head, and that's essential because, like, if your developers don't understand the product, then they're just kind of doing what they're told. They're not actually investigating. They're not actually understanding why they're doing what they're told. They're just doing it, right? And that's not a good place to be. I I think the other thing that happens in these small teams is you understand each other, right? Like your motivations are sort of largely shared. You have the same kind of aesthetics. There can obviously be differences within teams, but they tend to get resolved at the small scale, right? Like it's very hard in a small group to kind of spend your entire life in an antagonistic relationship with someone who you're spending most of your time with, right? And so these small teams tend to work better together because they all understand each other. They're like, oh yeah, that's Bob. He really cares about code review. Oh, that's Alice. She really wants to see product velocity. And they understand that aspect of things with each other. And they don't get as frustrated, right? So like all of the kind of interpersonal dynamics are just smoother. Whereas if like you only interact with another team once every month, you're more likely to get frustrated, right? And you're more likely to see each other as the enemy, which brings you to sort of the last part, which is you're all on the same team at this size, right? And in a small scale team, everybody more or less feels like they're on the same team. Right, and I can guarantee you, having been on some very big projects, in a big project, you don't necessarily, you sort of feel like you're all on the same team, but it's kind of more like, we're all roughly headed in the same direction, but within that team, there's rivalries and there's differences and there's all kinds of, different focuses, different interests, lots of different things going on, right? So I think the notion that this 5 to 6 person team is the ideal team size is pretty well founded. And I've certainly felt it for all of these reasons. But there's this problem, right, which is that most projects require an army eventually. Right? So there's this challenge of the fact that like if everybody had just ever tried to build stuff with 5 to 6 person teams, something like Kubernetes, something like .NET, something like Windows, it just wouldn't happen. You can't with the volume of work that is needed for projects like this. It just exceeds the amount of work that 5 to 6 people, no matter how efficiently and happily and understandingly they are working together, can generate, right? So we're stuck with this challenge of the fact that we need to be able to, or we want to be able to build software systems that require thousands of people to build. But at the same time, we are struck with the fact that these large-scale armies are just not super agile, right? Like if we look at sort of the classical army, it's a hierarchy, and everybody has their role. And to take the chess analogy forward, the pawns move in one way, knights move in another way, the king, and queen, and all of the different pieces, they have their roles to play. There's not a lot of agility beyond those roles, right? And so, I said earlier that you care about your users and you care about your product. There's an inherent agility needed in the development of all of these products that requires that you move in a way that a large scale, that the traditional way of organizing a large group of people just is not compatible. Right? Traditionally, to organize a large group of people, you establish a really big hierarchy. One person makes a decision, it ripples out, and yeah, you lose a little bit of detail along the way. But that is the sort of hierarchical pyramid is the traditional way of organizing large-scale people. But it just doesn't work for software, right? In part because there's all of these requirements around agility, and also, honestly, because in my experience, engineers are really bad at following orders. And actually, frankly, as an engineering leader, I don't want people to follow orders. Because as I said earlier, when you get down, you have to give people flexibility and freedom to both bubble ideas up, because they're the ones who sort of really understand what's going on, as well as to change orders on the fly, right? Because it could be that at the 30,000 view, it seems like one thing should happen. But down at the low level, it's actually like, well, I understand what you're trying to say with that. We need our reliability to be up. But the biggest problem with reliability isn't what you think it is. It's some other area. And if you don't give people the flexibility to make those sort of local adaptations, ultimately you're not going to be successful, right? Because if people are just sort of following what you are asking them to do, they're not going to do a good job. They're just going to do what you ask them, and you're becoming a single point of failure effectively because you have to be right 100% of the time. If you allow for flexibility and you allow engineers to sort of make their own decisions, you don't have to be right. You just have to be almost right. and then the people who are in charge of implementing them, those decisions can actually adapt to make it work. All right. Well, okay. So we sort of have this challenge, right? Which is that 5 to 6 person teams on one side, armies on the other. How do we get in the middle? And the answer comes back again in some ways to what I was mentioning earlier about object-oriented programming, which is that fortunately, software is modular, right? And so when we have thought about building software in the past, what we've realized is we can actually build pieces and widgets and then compose them together. And each one of those individual pieces can actually be based on, a contract and an interface. And if you look actually out into the world in general, this is sort of the way that people solve this problem out in the world as well, right? Like if you look, there's all sorts of interface standards out there, from things like outlets to things like fuel pumps to, many other pieces where people said, actually, we're going to introduce an interface and a contract, and that way, effectively, we can separate ourselves from one another and yet achieve great things together. Right? It requires the outlet manufacturers and the appliance manufacturers to, create power outlets and plugs that work together. But they don't actually have to coordinate other than that. They don't, if I'm building some great new appliance, I don't need to go talk to the outlet manufacturers and be like, hey, I have a dependency on your outlet. I need you to launch some new outlet so that I can launch my new appliance. It's like, no, there's one interface. As long as we build to that interface. And similarly, the outlet people don't have to go and ask all of the appliance people to refactor all of their appliances just because we're going to launch, a GFCI outlet or anything else like that, right? So this idea of modularity is crucial to achieving this balance of, on the one hand, small team sizes, and on the other hand, achieving big things. And so, as I said, microservices really is all about modularity and finding the right pieces in order to break up into these 5 to 6 person teams. All right, so what are the pieces that we need as we go along this journey? I think one of the most important things to think about going forward is thinking about how we plan, right? Because I think most of the time when we get stuck in these giant monoliths or when we get stuck in these giant organizations, it's not that we set out to build a 500-person team with deep dependencies and 3 days of dependency review every quarter in order to coordinate our work. It's actually that we just did a bad job planning to scale, right? And so I think that at this point, we have some degree of sense for how you plan to scale a service, right? We didn't used to. People didn't used to. They would go and take a web server and put it on a database and put it on a single machine and say, hey, look, or single container, and they'd say, hey, look, beautiful, my application's ready to go. And then they would say, and then you'd say, okay, well, but what happens when you need to scale? And they'd say, well, I just create another one. And then you say, well, but you have 2 databases at this point. And they say, oh, that's a problem, right? Because I can't have 2 databases, 2 sources of truth. I want 2 web servers because I need to handle extra load. But I can't scale my database. And because I chose the wrong atom at the beginning, my life is now actually hard, right? Because maybe I took dependencies on the fact that the database is on localhost, and so I didn't do really strict auth because I knew that nobody except for someone on the machine could do something. I'm not even using encryption possibly. I could have made a whole bunch of decisions back when I was here that actually make scaling really a challenging thing for me to accomplish, right? And so I didn't plan to scale, although, as I said, I think this is better understood now that you have to plan to scale your service. And when you start out, you're far better off if you say, okay, well, we have a web server in a container and a database in a container, and they're separate. And that way, if I need to scale, I just clone out a few more containers and I'm ready to go, right? We're good at doing this, relatively speaking. But I think I would argue that we're actually quite bad at planning to scale our teams, right? And so I would say that if there's one sort of message I want people to think about is when you're starting in a project, and obviously I understand that not everybody gets the luxury of starting a new project all the time, but when you're starting that project, great that you're thinking about planning to scale your service. Are you thinking about planning to scale your teams? And this goes beyond just, the software layout, although we're going to talk a lot about the software layout. But it comes to things like, are you building leaders? Are you helping people learn how to be better code reviewers? Are you helping people learn how to be better at operating the software? Right? Like all of the aspects of scaling, how do you go from a 5-person team to a 10-person team to a 100-person team to a 1,000-person team? That is just as important. That planning to scale like that is just as important as planning to scale your server architecture. And in fact, actually, I would argue that they're deeply intertwined. Right? That you can't build a scalable server architecture without building scalable teams. And if you do build scalable teams, you'll kind of inherently build a scalable server architecture. All right. What does this mean in terms of the actual characteristics for how we scale our teams? Well, I think that what this means I think that what this means at first is to really revisit how we think about our applications. I mentioned earlier that customers have all of these expectations about multi-screen experiences, about seamless data transfer from one device to another device across different networks. And I think that fundamentally then what we have to say is that products are a UX on top of APIs. Right? And so when we think about building, if we think about planning to scale our teams, we have to think about one of the very first separations, one of the first decouplings that we would do is separating from a back-end team and a UX team. Right? And having a crisp API that is the contract between the UX and the back-end. And if you're starting out and you're building a startup or you're building a new product, you actually probably don't have a UX team and you don't have a back-end team. But if you design your system so that the API is there in the middle, just like designing your system so that there's a web server and database that are separate, you've set yourself up to scale your team when you do want to have or you do need to have a UX team. Or alternately, if you've built that separation into your product from the beginning, you have the capability necessary when you decide, oh, we're going to not just do web, we're going to do mobile web and mobile devices. Potentially, set-top devices or wherever else it happens to be, right? So just like separating that web server and the database, if you say, hey, a product is a UX on top of an API, you've inherently set yourself up to scale your teams to having multiple different UXs, all living off of the same APIs, providing the same user experience. If you're tightly coupled between product and UX, between backend and UX, it's very difficult then to take the web UI and turn it into a mobile UI because the coupling is just way too hard. And similarly, so not only is it challenging from a product development perspective, but it's also challenging from a team perspective because if that line is messy, then your teams are hard to separate as well. Right? And so again, these things are tied together. It's not just about scaling your product, it's also about scaling your team, and they're one and the same. All right. So how do we actually achieve this sort of separation, right? One of the most important things in general is the establishment of these boundaries, right? I mentioned earlier things like the outlets, but and I spent a long time talking about how a product is a UX on top of an API. The API itself is a boundary. Right, and obviously with something like a web UI and a RESTful a web UI and a RESTful API, the boundary is very obvious. So it's an easy boundary to make, but it's not the only boundary that we would talk about. The database, if there's a database, a data service, NoSQL service, that may be a boundary as well. And then within that architecture, there's also a bunch of microservices. Maybe there's a background garbage collection task. We have to define all of these interfaces, and we have to kind of define them up front, right? There was a lot of time when we were doing object-oriented programming when people talked about object design, right? That was a thing that people spent a lot of time on, and I think it was because it wasn't just that it was a useful part of object-oriented, it was actually a different way of thinking than programmers had been doing, right? So we spent a lot of time sort of re-educating ourselves to think about boundaries and to think about interfaces and to think about encapsulation and what should be private and what should be protected and what should be public. right? And so I think that we actually, in some ways, sadly, didn't take those learnings forward into the designing of these distributed systems, right? And so I would encourage you, as you think about building scalable products and scalable teams, think about designing all those boundaries, right? Now, of course, the challenge is, and this is one of those other challenges, that like you can overdo it, right? I've gone into situations where I've talked to people and they're like, we've got 80 microservices. And I'm like, how many people do you have in your team? And you're like, we got 6 people on our team. And I'm like, well, that might be a little overdoing it. 10 services per person, maybe not the right ratio, right? So, again, we have to make sure that the complexity is warranted. And, sometimes you're going to have to refactor, right? You're never going to get it right up front, but you should try. And you should at least anticipate the first few cut points that you're going to need going out over time. In addition to defining boundaries, but maybe sort of inherent from defining boundaries, is this idea of decoupling, right? So in general, if there's a theme of microservices and the theme of these small teams, it's decoupling, right? So, it's not just a question of having different teams. You need to have different levels of access. Every team should have its own little workspace where you deploy the software, and only that team should have access to that workspace, right? Teams shouldn't all have access to the same database, because if everybody's partying in the same database, you're not decoupled, right? Everybody's deeply coupled through that database, and the shared resources that are within it, the shared schema that's within it. So I think you have to think a lot about not just breaking up, teams in terms of responsibility, but actually breaking up teams in terms of access, in terms of even technology, right? So that if you want to have different teams, they have the ability to make their own individual decisions. And I think that leads to that sort of decoupling leads to the corollary, which is you have to empower, right? So like it's not okay to just have an architect come in, define a whole bunch of boundaries, and say, okay, you get this API, you get this API, you get this API. Here's your keys to the cluster, and you should do this now. We have to, as part of the microservices and as part of the scaling of teams, we have to actually empower our teams to make their own local choices, to make their own local decisions, right? And so if we don't, if all we do is break things apart but we don't actually empower our teams, we're actually just making things more complicated, right? Because the whole idea of microservices and of building scalable teams is to encourage local autonomy. And local autonomy requires trust, which is scary, right? It's scary to delegate trust to a service. It's scary to say to somebody like, yeah, okay, I'm actually not going to pay any attention to what you're doing except for your APIs. But it is ultimately actually also way more agile, way more resilient, and way more performant, because that local level of empowerment enables people to move much more quickly and independently and achieve all those positive things that we talked about earlier that you get when you have that small team. But there's obviously, some corollaries. We can't just all run off and do our own thing, because it would be anarchy, right? And so there's a reason. I mean, Hamilton came out recently on Disney Plus, and I watched Hamilton again, and I thought, about early stages of the country. There's a reason that in the early days, when all the states were largely independent, there was a push towards a federal government. And the reason for that was because if you have all the different states making different commerce rules, it's very, very difficult to have interstate commerce, right? And so if we're saying ultimately all of these microservices are working together to build some product, we can't just have a bunch of massively heterogeneous microservices running out there with different interfaces potentially, or with different kinds of quality. There has to be some amount of consistency, or else building a product that is holistic on top of that becomes extremely challenging. So in addition, I talk a lot about separation and a lot about decoupling, but we actually also have to have some things that bring us together. So for a starter, so these are sort of the ground rules that I think you need to establish for all of these microservice APIs as we go forward. One of the most important things to think about is a deprecation policy, right? And I think it's kind of shocking sometimes how few people have thought about this. I think everybody who's working on a programming language like .NET think about things like deprecation policies. When is it okay to remove an API? What's the cost of removing an API? But I think that we, as people who build distributed systems, don't necessarily think of that. Obviously, in the public cloud, we think about that with our public APIs. But I would say it's not just about your public APIs. If you really want to encourage microservices, you have to have deprecation policies for your internal APIs too. You have to have deprecation policies for data schemas, and you have to have deprecation policies for every service you provide, because if you don't, then you're introducing coupling, right? If you don't have a deprecation policy, then in order for one team to do something, another team has to move. And that sort of connection of hey, we're about to take out this API. Oh, we can't, now suddenly I have to change my code because you're taking out an API, and I have to change it on your schedule, not on my schedule, means that I've coupled my teams together, right? So every single service that you have has to have a deprecation policy. This really is something, again, you need to put in up front. Similarly, you have to have documentation, right? I mean, in general, I guess I would say that you need to treat every single microservice API that you build like it's an externally public API, or like your customers are, your internal customers are the same as your external customers, right? There is a sort of notion of first party equals third party that is a critical aspect of delivering on microservices, because if you don't do this kind of thing, then you're introducing, again, coupling between the teams, because in order for me to go and learn about what your API is like, I have to actually go and talk to you. And I'm not saying that talking to people is bad necessarily, but it is sort of a form of coupling that limits my ability to move independently, limits my ability to move agilely. And also I think in general, just forcing people to document their APIs means that you're actually treating it like it's a product, right? Because again, one of the most important things that 5 to 6 person team can do in delivering that microservice is to truly believe that their microservice is their product. Something that they're proud of, something that they put out there into the world that they have customers of, and documentation is a part of that. And then the other part of being proud of it is quality of service, right? So if I'm taking a dependency on you, of course I want to know that the application is going to work well, but actually I need more than that, right? I need someone to stand up and say, this is my SLO. At the 99th percentile, this is what my latency is going to look like. This is the level of reliability that you can expect, right? Because if I don't do that, there's 2 problems with it. One is, as a developer, I don't know how to plan then, because if I don't know how high quality, if I don't know the quality of service that you're going to deliver in your API, it's hard for me to build against it and build a reliable service against it, because I just don't know what to expect. Is it going to fail half the time? Is it going to never fail? I can build against either of those APIs, but the way that I build against them is going to be different. Where I put my energy is going to be different. But I think the other really important part about quality of service is actually has more to do with debugging and figuring out what happens when things go wrong, right? Because one of the real problems that happens in a lot of these microservice architectures is that if there's a problem that is at the intersection of 2 microservices, there tends to be a lot of finger pointing, and the customer experience falls into the chasm between the microservices, right? So if I can point at you and say, hey, it's your fault, and you can point at me and say, hey, it's your fault, the customer doesn't care at the end of the day because it doesn't work for them. But the 2 teams can play blame games for weeks and not try and actually resolve the issue. If you have quality of service as a metric and you say, look, we're going to deliver 99.9 availability, and then you monitor that on both sides, right? So the service provider monitors it, the service receiver monitors it. You can actually look at the monitoring and say, well, did you deliver on your SLO? And if you did, then it's the client's fault, and if you didn't, then it's the service's fault, right? So the arguments about whose fault it is really go away if you really crisp and formally define the quality of service for your APIs. It's a critical thing to get right. And then in general, this idea that you need to push teams to interact via APIs, right? So teams need to interact with each other just like a customer, an external customer would, and not have backdoors and not have, oh, we all just uploaded something to this storage bucket and then somebody else downloads it from that storage bucket. I mean, that could be an API, I guess, but it has to be formalized, right? There can't be any backdoors. And this leads to a lot of different important consequences. The first is this idea of don't ask, don't tell, right? Which means I'm not going to ask you about how you implemented your thing. I'm going to ask you what your API is, where your documentation is, and what your SLO is. but I'm not going to ask you how you achieve that SLO, and I'm not going to even care. And this is actually quite hard for engineers, right? Because engineers kind of really want to understand, how the sausage is made, how the thing works together. And so telling an engineer, like, I'm actually not going to tell you how I did it. I'm just going to tell you that I'm going to deliver this SLO is not an answer that engineers like to hear. But it is actually a really important aspect of the decoupling. Because if I understand how you're delivering on an SLO, I will understand that, I can actually take a dependency on specific behaviors of your API that may not actually be public, right? I can take very strong dependencies on implementation details effectively. And at that point, I'm tightly coupled to your service implementation, and I have made it impossible for you to evolve that implementation over time. So I'm really not supposed to ask you anything except for the characteristics of your API as defined by the formal API in the documentation and the quality of service metrics. And similarly, as an API owner, I cannot tell you. As much as I would love to share with you the details of how awesome I built my API, I shouldn't tell you because now I'm also enabling you to take deep dependencies that don't allow for coupling or that produce coupling. Similarly, I think this idea of trusting no one, right? It's really important that when you deliver these APIs, you deliver them in a way that you anticipate a hostile user. Because the truth is that people are going to be hostile, even if accidentally so. They will, DOS your API. They will call with bad certs. They'll call into production from a debug environment. If you really treat every single microservice API as if the public is on the other side, first of all, you'll build a more secure system because you'll encrypt everything everywhere. You'll ensure that there's proper authentication and authorization everywhere. But you also build a more resilient system because you'll have rate limiting and you'll have all of the and you'll have, the ability to ensure that debug traffic doesn't go talk to production in ways that if everybody kind of trusts each other, don't work out, right? And so in some ways, this is the same reason that we don't do cooperative multitasking in operating systems because even though it's all one operating system and even though it's one program, it's really much better if the programs don't trust each other. And then I think also it's really important to dog food your own APIs, right? So as you build these microservices, it's extremely important that you maintain the same sort of hygiene that you expect of your end users and the expect of other service teams of yourself. So just as I said, don't have backdoors, don't have leak implementation details to your customers or to your users. You really have to have the same hygiene for yourself because every backdoor that you leave open is something that someone else will take a dependency on. Even if you really say, you know what, we're only going to let internal teams do these kind of things, or internal people close to my team do these sorts of things, it's just not going to, it won't stay that way for long, right? And so there's all of this sort of isolation that is an essential part of delivering on these APIs, on delivering on these microservices. But there's also one last problem, which is that actually if you allow for all of this hiding and encapsulation, you actually allow for a ton of heterogeneity, right? And so you're going to have a bunch of different developers choosing a bunch of different programming languages. Some of them might even choose Java, although we try and avoid that in most cases. And this heterogeneity means that you don't have portability between your teams, right? If somebody wants to change their job for whatever reason, move to a different country, move to a different team, just have a different experience. It's difficult if there's this kind of heterogeneity, if there's this sort of polyglot nature. I'm not suggesting necessarily that you have to standardize on a single language, but standardizing on one or two, three or four is probably a good practice, right? Similarly, you could have people arguing about YAML and JSON and someone off in the corner still arguing that XML is a good idea. You have to, again, establish consistency in data formats and also in things like front-end development, right? Like you don't want to have your one UX written in Angular, another in React, another in, somebody still using jQuery, and God forbid somebody still using PHP. We have to establish core infrastructure, right? So it's not just the case that in microservices we want to say, okay, it's just the Wild West. We don't trust anybody. We establish these hard boundaries. We treat everybody like they're external. We do our own thing. We have to establish core infrastructure. We have to choose things like languages. We're going to say, hey, we're going to choose 3 languages. Those are the only things we're ever going to use. We're going to make choices around packaging and development. So, at this point, I'd say containers and container images are the choice for packaging and deployment. There's no reason to do anything else. Standardize on that, standardize on a way of building these containers, standardize on a base image so that if you have security challenge, or if there's a security issue, it's very easy to patch all of your images moving forward. Standardize on core infrastructure, like continuous testing and delivery, right? There's no reason for anybody to, for one team to use GitHub Actions, another team to use Travis, and another team to run their own Jenkins box, right? Standardize on one thing. I'd argue for GitHub Actions, but that's just me. But standardize on one thing as a piece of core infrastructure so that, again, there's consistency for your teams across. Similarly, for monitoring and logging and alerting, you don't want to have 14 different ways of sending pages to people because you're going to have different apps and different, APIs and all sorts of problems where teams, can't, forward an alert from one system to another. So standardizing on everything having to do with the operations of your software is a critical component, right? And there should only be one, right? So we make this big argument about lots of microservices and all sorts of heterogeneity. But there's places where actually just deciding and saying, hey, look, we're going to use Grafana and Prometheus and PagerDuty or whatever it happens to be to do your monitoring, logging, and alerting. That's a requirement. You just can't have teams make their own decisions in this place. Similarly, there's a lot of core infrastructure, and I think especially around how you deliver these APIs that is essential to be shared. Right? So it's not okay to just say like, well, everybody puts on a JSON HTTP service and go nuts, right? You actually need to have deeper. You need to have a shared implementation of what that web server is. That's going to include things like shared implementations of authorization and authentication, shared implementations of rate limiting. I've gone through this recently where we discovered that multiple teams have different implementations of rate limiting, not even just that the implementations are different, but sometimes even that the algorithms are different. And it's a horrible customer experience, right? Because when I talk to one API, I get throttling information back in one way with one algorithm, and if I talk to a different API, I get throttling information with different headers and different status codes, and possibly even a different implementation that affects how I respond to being throttled. It's very, very difficult for me. I'm constantly putting in special cases, and the knowledge that I learned in one area doesn't translate to another area. So having that core shared infrastructure, not to mention having to do things like certificate rotation and things like that, those are problems that really you don't want each individual team solving because they're going to do a poor job, and also it's just going to be inconsistent and frustrating. And I sort of talked about this already, about how secrets and things like that also need to be, right? If you have certificates anywhere, think about how hard it would be to turn on auto rotation. If you can do it once, then you're in the right place. If you're thinking, oh my God, if I had to get every team that I work on to do auto rotation of certificates, and it would take months or years, I would say you don't have the right kind of shared infrastructure in place. Similarly, for storage, you have to have a team. I mean, I would argue that storage is a microservice unto itself, whether you're using a cloud-based storage, in which case you've sort of delegated the microservice out to a cloud, or you're developing teams that are responsible for running your databases or running your NoSQL stores or running even just block storage. Treating storage like it's a microservice and not letting each team do storage both builds better patterns because the teams aren't going to build stateless instead of stateful applications, but also builds better consistency because you're not going to end up with 14 different versions of SQL Server running around. You'll have one consistent database that everybody, or at least one consistent database version that everybody uses. And again, that helps with performance tuning, that helps with security, that helps with any number of these really important aspects of delivering on a good application. And then finally, building out shared infrastructure for analytics and experiments. This is one of these things that people don't ever do in the beginning and always regret at some level. Like, you're going to get to a place where you need to do experiments, A/B experiments, where you need to understand, like, why are my users churning? And if you don't have shared experiment infrastructure built into every piece of your API, if you don't have the ability to do request tracing from the browser all the way down to the database, it's going to hurt you ultimately, right? So this is a key aspect of the shared core technology to deliver into the middle. All right, so we've gotten to the end. Hopefully that was entertaining, and hopefully my network didn't fail 2 minutes in, because whenever I do these virtual presentations, I'm always terrified that I'm only speaking to my cat and my neighbors who can hear me through the walls. But looking back, talking about and hopefully looking forward to the rest of the microservices day that you have in this dotNETConf, I want to encourage everybody to focus on scaling their teams. I think that if you focus on scaling your teams, you'll inherently be able to scale your service. But I think that the opposite is not always true, right? If you focus tightly on scaling your service but not on scaling your teams, you're not going to do the human things and possibly not even the API design things necessary to scale your teams. Think in APIs. This is kind of like that object-oriented revolution in the 80s where people started saying think in classes. Think in terms of APIs, think in terms of rate limiting, think in terms of authentication, think in terms of API design. Everything has to be done through an API. That will really help you get to a microservice architecture. Focus a lot on empowering individuals, right? Because getting to this level of microservice really has a lot to do with enabling independence and enabling people to do the right thing in the right places without having to check in with some astronaut architect or some central board governing that tells people how to deploy software. And that's an incredibly important part of the microservices revolution. But also at the same time, build on shared infrastructure, right? So it's not just all about everybody being a cowboy coder out by themselves. There is also a ton of this shared infrastructure that is an essential characteristic and is also a huge accelerator, as well as something that is important from a human perspective, because while it's great to build these 5 to 6 person teams, the truth is that over time, as people's career evolves, you're going to need portability of people across those teams. And if you have shared infrastructure, people's career portability will be a lot better. They'll be able to jump from one team to another and hit the ground running. So I'm done. Thank you so much for listening. I hope it was entertaining. You can find me out on Twitter at Brendan D. Burns anytime. I'm always eager to chat. And I hope you have a great dotNETConf, and I look forward to speaking to you again. Thanks. I guess I should have 2 minutes for questions.
Yeah. Thank you so much, Brendan. Really appreciate you. I got to put the headphones on. There we go. Can you hear me now?
I can hear you now.
Fantastic. So there were some really good questions that came through. Folks on Twitch and on Twitter, really excited, and I see some folks saying that they're halfway through building some microservice architectures, and they're inspired now to finish and move forward with some of those projects that they're working on. But I want to go to, there's a question here that came through on Twitter. Let me grab the tag board here and start sharing that so we can take a look. There's a question here from Nilesh that you might be able to help him out with. Can you mention some points on how to think towards migration from monolithic apps to your microservice-based application?
Yeah, for sure. I mean, I think there's 2 pieces to this. One is, as I said at the beginning, like if you're happy, like don't do it for tech. You got to have a reason. So make sure you understand like why, because I think that helps. Understanding why you would want to break up a monolith helps you understand how you want to break up the monolith. Right? Because maybe there's just like 2 services that are part of the monolith that, need a different kind of scaling, right? So you need to break it apart because you don't want to scale in monolithic chunks. You want to scale another service different from the monolith. And so then it makes sense to just break out that one service, right? Or break out those 2 services. Or maybe, you need more agility or experiments. And so in a particular area of your app, so it makes sense to break out that part of your app. I think my one high level general advice is, the V2 never works, right? So if you say, hey, like we're going to create a wholly separate team, got the monolith team here, they're delivering features, keep on going. We're going to create our new Tiger team of V2 people, and they're going to go and spend 9 months building the V2 and then launch it, and then we'll turn off the monolith and launch the V2. That never, ever, ever, ever works, right? So you're going to have to evolve in place. You're going to have to evolve over time. You're going to have to evolve with the same team, right? Because no team likes to be like the legacy team. Right, that's death. Right, so like you'll lose. Not only will you have a hard time, but actually all your developers, all your best developers, will immediately leave the legacy team, and that's very, very problematic. Right, so that's my failure story, which is don't do the V2. That means you're going to evolve your monolith in place, and then looking at kind of what you want to achieve, what your motivations are for going to microservices, helps you figure out what pieces of the monolith to break up. And if you only break off like 50% of them, but you achieve 95% of the value that you need, that's great. Stop, right? And then just have like the 50% monolith, and it just lives on, and that's not a problem because you've achieved the goals that you needed to do. The goal isn't to get to perfect or perfect microservice architectures. It's to, empower your users and your product and your teams.
Very cool. Oh, thank you so much for joining us today, Brendan. We really appreciate it, and some good insights to get folks started with thinking and planning towards microservices. Really appreciate it.
Absolutely. Have an awesome time, and yeah, thanks.
All righty. And we'll be right back with our next speaker, Kelsey Hightower.